welcome to the third tutorial on Tidyverse, where I will talk about reshaping and recoding your data. My name is Wouter van Attenveld of the Vrije Universiteit Amsterdam, and if you want more information you can go to my website at vanattenveld.com/r, which essentially contains a link to these video tutorials. It contains a very exciting link to our upcoming new book on computational social science, and it also contains a link to the GitHub page where you can find all our handouts. And today we will be working with the handout called Reshaping Data. So if you go there, you can follow along and follow all the code that I'm running with some extra explanations. So just go to vanattenveld.com/r, follow the link to the GitHub, and then you can find the handouts under Reshaping Data. Alright, so like before, we will be mostly using the Tidyverse library, and in this case we will be using two datasets published by Piketty as part of his book Capital in the 21st Century on income inequality and wealth inequality. And what we'll be talking about is, of course, reshaping from wide to long and reshaping from long to wide. What it means essentially is that if you have a dataset with lots of columns, and all of those columns are, for example, one country, and there are the same measurement of each country, like the inequality in that country, that is what we call a wide data set. And we can transform the wide data set into a long data set by basically flipping it around and turning all the columns into rows, and then every row will contain one measurement of one country. And of course, long to wide transforms it the other way around, from a long data set back to a wide data set. Besides wide to long and long to wide, there's two topics for today, namely separating columns, so one column contains multiple data points, and recoding data to change the values of the columns. To start with the first one, let's have a let's read in the income data. We'll call it D, or actually let's call it income, and let's have a look at what we got. The income data here is a dataset which a row for each year, a column for each country, and each cell contains the percentage of the income that the top decile got in that year. So in 1900s, the top 10% richest people earned 41% of income in the US, and actually that made the US the most egalitarian society at that point compared to the other ones, which all had high 40s in terms of how much income went to the top decile. Now, you can also see that for some reason it doesn't include all the years between the 1900, 1910, 1920, etc. But it includes a row for them with only missing values. So let's get rid of these missing values by using the na-omit commands. Right, so this looks better, and now we can actually see that there are in fact values from 1900 until 2010 for each of those countries. This is what we call wide data. We call it wide because there's identical measurements for multiple cases, and these cases are in the various columns. In most cases, long data is easier to work with, and tools like ggplot assume that you have long data. With long data, I mean that every row would contain a country. So there would be one row for 1900 US, one row for 1900 UK, one row for 1910 US, one row for 1910 UK, etc., etc. To convert from wide to long, we use the pivot longer function. If you if you've been doing this for a while, you'll know that there used to be called a melt and cast functions. Pivot longer is basically what used to be called the melt function, because you melt the data to a long format. But we call it pivot longer. We pivot the data to become longer. And for pivoting data to become longer, you need to specify the data, of course. So it's the income data. Then you need to specify which columns we want to pivot. In this case, we want to pivot all the columns from the US to Europe. Oh, and I can't type Europe. And in fact, that's it. So now it already made long data. So now we have 1900 US 41%, UK 47%, etc. Very often it's easier to specify which columns we don't want to include in pivoting, in this case year, by using a negative selection, just like you could do with the select commands. And so this does exactly the same. These two in this case have identical results. Finally, you can give a number of options, and especially we can control what it should call the names. and now it calls it the name column, but it would be much nicer to call this the country column. Of course, we could rename it afterwards, but it's nicer to get it correctly immediately. And let's call the values column the income top decile. And so now we have a data set with the year, the country, and the income top decile. Now, why is this so much nicer? A very quick example, if we wanted to plot this, actually we should then save this, of course. So let's save this, and now our income data became divider. If we now want to plot this, we could ggplot it and put the year on the year capital letter, yeah, capital letter, year on the x-axis, country on the y-axis, and we could have the color of the line be the country. Sorry, the y-axis, of course, not the country. The y-axis is the income top decile, and then voila! In one simple command, we have our ggplot. Oh, sorry, I'm stupid. I have to tell it actually what to plot. We want a line plot, and there we go. So because it's long data, it can immediately use the color to signify the data. Otherwise, we'd have to make a separate line element for each of the columns, and that would both be redundant, but also it wouldn't make it clear that these actually are all measurements of the same thing on different countries. So something like ggplot prefers your data to be white, and in many cases, if you want to do other calculations, it's also much nicer for it to be white. Let's now look at the other data set, the wealth inequality data set. So let's have a look there. We'll call it URL for wealth, and we'll call this, of course, wealth. So what does this data look like? This actually looks a little bit more messy, right? Let's view it over here. That might be easier. So here you can see that in 1810, there's a column for France top decile, a column for France top percentile, etc., and actually for different countries, and then interestingly, it also has it for Europe, and then it also has it for Paris, but only the percentile. And so this is quite a messy data set, or at least a data set that's not as it's not really a rectangular data set, because the columns actually don't even all contain the same thing. So what we want to do is to convert this to a data set where we can immediately see 1800 France decile is this value, 1810 France promile is this value, right? To make it easier to work with. And also we want to get rid of all those missing values, but we can't simply do NA omit, because then it would get rid of every row that contains a single missing value, which basically means that we get rid of all the rows that we have. Because in fact for the United Kingdom top promile, we don't have any data. Why this is included in the data set, I don't know. I suppose you'll have to ask Mr. Piketty. Right, so we're going to pivot this data, which is going to be very similar to what we already did. Actually, we won't give the values column here. So let's see if this works out of the box. And there we go. So now it says year, country, value. And actually, this is not the country. This is the country and the measurements. So let's not even remain in the country, and let's just pivot it like this. So then we have a year, a name, and a value. Now, this was simple, right? It actually went exactly the same as for the income data sets. But now we have the problem that our name column actually contains two separate values. It has the country and it has the measurements. So what we're going to do, and of course first we need to actually store the result of the pivoting. What we're going to do is use something called separates. And separates, you give it the data, you give it the column you want to separate, and you tell it what it should be separated into, and you can give it a separator to do the separation with. So the data, and in this case of course is wealth. The column is the, I think it's just called the name column, and it should go into two columns, namely country and measurements. Right, let's see if that works. And that works fairly well, only interestingly it split United and Kingdom into two columns, because it by default it splits on spaces. So let's actually tell it what it should split on, and in our case we want to split on a column. Now this is much nicer, right? So we have countries. Paris is not really a country, but we'll ignore that for a second. And we have measurements, and then we have values which are sometimes missing. Now the only ugly thing is that there's still a empty space before every measurement, because I split on a colon, and of course the colon was followed by an empty space. There's a couple things we can do here. The easiest is probably to just add a space there. Another option would have been to then mutate it and say that the measurement equals the trim white space from the measurements. We'll learn more of these nice tricks once we start looking at text and string processing. But for now we'll go with a simpler solution and just separate on colon followed by a space. So let's call this wealth again, and you'll see that by default it actually dropped the name. This column is gone. It's now split into two different columns. Right, so we have seen how to use pivot longer to turn a wide dataset into a long dataset. And we created a dataset called the wealth dataset, which has the year, the country, the measurement, and the value in each row. Right, this is what's in Tidyverse they call a tidy dataset, because every row has exactly one measurement. However, sometimes we might wish to actually undo this operation and turn the rows into columns again. And as you might have guessed, this is actually called pivot wider. And if we want to do pivot wider, we of course supply it with the data frame, which is in this case wealth. And we tell it where the names come from, right? So here we tell it where the names go to and the values go to. Now we say where the names come from. So in this case, let's put the measurements into the columns. It's not called measurements, it's called measurements. And because the values were called value, we don't have to specify it. We could also explicitly say that it should come from value. It's the same result, right? Because value is the default name for the values. And you can see here that it now has 3 new columns. So we have a column for each measurement type. Whether you want to keep it long or whether you want to keep it wide depends on what you're going to do afterwards. Possibly if we are going to join this at the country level, it might be nicer to have only one row for each country, right? So for example, suppose we want to merge the wealth data with the income data. The income data is at the country level, so then we probably want to have this at the country level as well. So now we have the 3 different columns. One very useful trick to know is that if we have missing values here, so let's actually get rid of those missing values there, right? So we've dropped the rows now. So if we now pivot it, and you'll see it creates missing values because there is no row for 1810 para stop decile, right? Because we dropped that one. So 1810 has France stop decile and para stop percentile, but there's no para stop decile. By default it gives you a missing value here, but in some cases, for example, if these are counts, how often something happens, then not having a value might mean that you have a 0. In that case you can supply the values fill, call it a 0, and then all the missing cells are replaced by a 0 rather than a missing value. Now in this case of course they're truly missing, so there's no, we won't actually do that, we'll keep them as missing values. Right, so now we would like to join the wealth data and the income data, which at the column level is okay, right? Because it has year and country, and it has year and country here, and then we have 4 measurements for every year country combination. So that's good enough. However, if we would table which countries are included, we'll see that in the wealth we have the United Kingdom and the United States, while in income we have UK and US, and also wealth has Paris and income has Germany, right? So there's some countries different, but mostly we would really want to standardize how we refer to United Kingdom and United States. So the first thing we need to do is recode the data. There are a number of ways in which you can do that, but I think the best way to do this is to actually use the recode commands. So we're going to say we're going to mutate the wealth data, and we're going to say the country equals the recode of the country, and United Kingdom should become UK, and United States should also become US. And then for the income we do the same, only then this was called u.k, and this was called u.s. And so now it has UK US, and of course to actually remember the results we need to assign it to a variable. In this case we give it the same name again, so we just call it wealth and income again. Now if we look at which countries are included, the list is much nicer. You'll see Germany here wasn't in the other one, and Paris here isn't in the other one, but we're getting close to this. So Recode is a very useful little function that you can use if you have different ways to refer to the same thing. Maybe you have different groups or different respondent numbers or whatever it is. So if you want to give a list of if it's this, then it should become that. If it's this, then it should become that. I won't go into them now, but alternatives are if else. We've used that one before with the North American example, if you have only two options. So we used Recode if you have many options. And then there's something called case when, which is very useful if you have more complicated conditions. So if you want to say if it's bigger than 10 but smaller than 20, then it should become this group. If it's bigger than 20 but something else is going on, it should become that group. That's where you can use case when. So these three functions are very useful if you need to make some small changes to your data like this. Now finally, let's filter the data. So we can say wealth equals the filter of wealth, where we want to get rid of Paris. So we can say country is not the same, is not equal to Paris. And we do the same for income, and we get rid of Germany. So now if we look again at which countries we have, then it's an identical set of countries. So now the data are very similar, right? They share two columns, they have the same rows, so it should be very easy to join them. Right, so let's actually join the wealth and income data sets. We use the inner join here, so it only takes rows that occur in both data sets. In this case we made sure beforehand that all the rows are equal, so it doesn't really matter which of the joins we take. If we do the inner join, then it automatically says it's joining on year and country, because those are the shared columns in the two data sets. And we'll see that in 1900 in France, the wealth inequality was for the decile was 87, so 10% of the population had 87% of the wealth, and 10% of the biggest earners earned 46% of the income. So let's call this our inequality data, and we could now plot this data. For example, we could say we plot the inequality, and we add a nice little line where we say the x equals the year, and the y equals the, for example, the income inequality, top decile, and the color is the country. And let's make the plot window a little bigger so you can actually see what's happening. And so here you see again the income inequality that we saw earlier as well. What is nice now, because it's one data set, we can quite easily also add a line for the wealth inequality. So then we don't use the income top decile, but we use the, what is it called? I think it's simply called top percentile. So top, that is the income top decile, this is the wealth top decile. And now we have two sets of lines, one with the income inequality, one with the wealth inequality, and probably we want to dash one of them, so we'll call this line type equals dashed. And now you see dashed lines for the wealth inequality, and solid lines for the income inequality. Now this works, this is fine, and frankly we wouldn't even have to join it. We could have used different data sets for the two lines, but it's still a little bit clumsy, for one thing because we have to add two different line elements that seem to ggplot like they're totally different, but in fact of course they're the same type of measurements, and we don't get a legend for what it means for solid versus dashed. Of course we can add a legend manually, you can solve all these problems, but they are caused by the fact that our new beautiful joint data set is in fact again a wide data set. So we have a year and a country, and then a bunch of measurements on that year and country. So what we can do is we could actually pivot it to become longer again. the inequality data sets. And now the columns are everything except for year and country. And then we say that in 1900 France, the top decile wealth inequality was this, the income top decile was this value. So now we have a long data set representing the same data. And this we could plot, and I'll use the pipeline notation here to immediately feed the result of the pivoting to a ggplot. We can plot this data, and we could say the X is the year again, the color is the country, the Y is the value, and now we could say that the line type equals the name. And then all of a sudden we get all the lines if I would have asked for a line. And now we get all the lines for the income top decile, the wealth top decile, wealth top percentile, web top promile. So now in one command, because it's long data, we actually get all of the different measurements instead of having to get a line for each measurement type, and we automatically also get a legend that tells us which is which. Now this is a little bit too much information, I think. So what we'll do is we'll filter that we only want name to be either income top decile or wealth top decile. And voila, now we have the same plot as earlier, but with a single ggplot command, and we have the legend that we were looking for. The big lesson here, I suppose, is that if you have long data and if you have wide data, sometimes it can be nice to have it a little bit wider, because then you can align the rows with another data set. Sometimes you want it to have longer data, for example, if you want to plot it or if you want to do extra calculations. However, if we wanted to, for example, take the correlation of the top decile with the income top decile, it would be much easier to do in this data set, because then we're just correlating two columns. Then in the long data set, so whether you want your data to be long or wide really depends on what you're going to do with the data, how you want to analyze it, etc. The biggest lesson, I think, is that it is really easy to pivot from longer to wider. And in fact, what we've seen here is what we did to create these plots is we got two data sets from the internet. We pivot them both into longer formats. Then especially with the wealth data, pivoting into the longer data set meant all these silly column names with the country and the measurement in them were now stored in one column, so we could separate them in one command. But after that, we pivoted them to wider again, so that we get the country as the unit of analysis. Then we could join them, and after joining them, we could pivot them back to longer to get the measurements in the different rows again. And so what you see here is actually, in many cases, complicated data reshaping and data joining commands are in fact often solved by combinations of pivoting to longer, pivoting to wider, doing calculations, and sometimes you need a combination of these to form a sort of pipeline of your data restructuring and data cleaning operations. As before, have a look at the handout for this, right? So look at the handouts. It goes through the same code. It gives extra information. It ends up with a plot that's actually a little bit nicer with a facet grid. So if you want to learn that, have a look at the handouts, go through it. And of course, as always, you can just run the code as it is in the handouts, but also just play around with it, right? Either with the different options or see if you can get a different data, get a different analysis from the data. Just have fun, and remember, you can't actually break anything. So, all right, good luck and see you soon.